Now let's discuss another Cauchy problem for the one-dimensional homogeneous wave equation. The problem is let uxt be the solution of the Cauchy problem utt minus 9 into uxx equal to 0 minus infinity less than x less than infinity and t greater than 0 with the initial conditions u of x is 0 equal to fx is equal to 1 when mod x is less than or equal to 2 and 0 when mod x greater than 2 and ut at x0, that is g of x, which is also the same split function, that is 1 when mod x less than or equal to 2, 0 when mod x greater than 2. Then the first part is find u at 0 1 by 6, 0 comma 1 by 6, or when x equal to 0 and t equal to 1 by 6, we have to find the corresponding value of u. And the second part or second problem is discuss the large time behavior of the solution. By D'Alembert solution, we will have u of xt as the solution, and we have to discuss the or we have to check the large time behavior. Large time behavior means for a fixed value of x, we have to find the value of u as t tends to infinity, or the limiting value of u as t tends to infinity. That is the large time behavior of the solution. Then the third question is find the maximal value of uh, u of xt and the point where this maximum is achieved. And the fourth problem is find all the points where u belong to C2. We have to find all the points where u is a twice continuously differentiable function. Okay, so let's do one by one. For the A part, we have the D'Alembert. Since the given problem is a Cauchy problem, solution is given by the D'Alembert solution. D'Alembert's formula, that is the solution of the given Cauchy problem by D'Alembert's formula is given by u of xt is equal to 1 by 2 into f of x plus ct plus f of x minus ct plus 1 by 2c integral x minus ct to x plus ct g of s ds, where small f and g are the given initial the functions in the initial conditions. Okay, so consider the our problem. Here the problem is utt minus 9 uxx equal to 0. So here c square equal to 9, therefore c is equal to 3. Let this be equation number 1. Okay, with the given initial conditions, let this be u of x 0, u of x0 is equal to 1 when minus 2 less than or equal to x less than or equal to 2, and 0 when mod x is greater than 2, that means x is less than minus 2 or x greater than 2. Okay, and this is the function f of x, and both are same, g of x, which is same as the g of x. Both the functions are the same, that is ut at x0 is also is equal to g of x, also equal to the same function as f of x. So this be equation number 2. Okay, now we have to calculate u at the point 0 1 by 6. So we're substituting, now put x equal to 0, t equal to 1 by 6 in the given solution. The formula for the solution, that is, let this be star. So the star equation will becomes u at 0 1 by 6 is equal to 1 by 2 into f of x plus uh, C 3 into t is 1 by 6, that is f of 0 plus 3 into 1 by 6 plus f of 0 minus 3 into 1 by 6 plus 1 by 2c, 1 by 2 into 3, that is 1 by 6 integral x minus ct, that is minus 1 by 3 2 plus 1 by 3 x plus ct will be plus 1 by 3 g of s ds. This is equal to 1 by 2 into f of 1 by 2 plus f of minus 1 by 2, sorry, not 1 by 3, that is 3 by 6, it is 1 by 2 of 1 by 2 plus 1 by 6 into integral minus 1 by 2 to 1 by 2 g of s ds. And we know that f of x has the value 1 for minus 2 less than or equal to x less than or equal to 2, and g of x also have the same value. So whenever x is equal to 1 by 2 or minus 1 by 2, both values lies in this interval, and hence the functional value is equal to 1. So this is equal to 1 by 2 into 1 plus 1 by 6 into integral minus 1 by 2 to 1 by 2 1 ds. So this is equal to 1 by 2 into 1 by 2, that is 2 by 2, that is 1, plus 1 by 6 into um, s from 1 by 2 minus minus 1 by 2, that is 1, which is equal to 7 by 6. Therefore u at 0 1 by 6 0 comma 1 by 6 is equal to 7 by 6. Now we try to find the second problem, B part. That is, the problem is discuss the large time behavior of the solution. That means we have to find for a fixed x, we have to calculate limit t tends to infinity u of xt. So here first we fix x is equal to theta belong to R. Then we have to calculate, or we have to compute limit t tends to infinity u of theta t. Okay, so limit by definition, limit t tends to infinity u of theta t is equal to limit t tends to infinity 1 by 2 into f of x plus ct, theta plus c 3t plus f of theta minus 3t in bracket plus 1 by 6 into integral theta minus 3t into theta plus 3t uh, g of s ds. So we need to find what will be f of theta plus 3t and f of theta minus 3t as limit t tends to infinity. Also, we have limit t tends to infinity f of theta plus 3t. We know that f of x is equal to 1 when mod x is less than or equal to 2, and 0 when mod x is greater than 2, or x greater than 2 and x is less than minus 2. The same for g of x also. So if when theta is a fixed theta plus 3t, as t tends to infinity, theta plus 3t also goes to infinity. That means for all values other than minus 2 to in the interval minus 2 to 2, the value of f of x is 0. So obviously this will be equal to 0. Now, similarly, limit t tends to infinity f of theta minus 3t. And we have when theta is fixed, as t tends to infinity, theta minus 3t belongs or tends to uh, minus infinity, then also the value of f of x will be 0, isn't it? So we have this is also equal to 0. Now we need to calculate limit t tends to infinity. Limit t tends to infinity integral theta minus 3t theta plus 3t into g of s ds. This is same as integral limit t tends to infinity theta minus 3t means minus infinity, and theta plus 3t will be plus infinity. So this is equal to integral minus infinity to infinity g of s ds, and we know that this we can split as integral minus infinity to infinity g of s ds can be splitted as minus infinity to minus 2 plus minus 2 to 2 plus uh, 2 to infinity, and so this the only things remaining will be the interval minus 2 to 2, because the other two in the other two intervals g of x is 0. So this is 0 plus minus 2 to 2 g of s ds plus again 0. So this will be equal to, when minus 2 to 2 g of s is 1. So integral minus 2 to 2 1 ds, that is equal to 4. So limit t tends to infinity theta minus 3t into theta minus 3t to theta plus 3t g of s ds is equal to 4. Substitute this in uh, this equation. Let this equation be number 3. Okay, so therefore from equation number 3, limit t tends to infinity u of theta t. Limit t tends to infinity u of theta t is limit t tends to infinity 1 by 2 into limit t tends to infinity f of theta plus 3t plus f of theta minus 3t plus limit t tends to infinity, oh sorry, 1 by 6 into 1 by 6 into limit t tends to infinity 1 by 6 into limit t tends to infinity integral theta minus 3t to theta plus 3t g of s ds. So this is equal to 1 by 2 into first one is 0, and limit t tends to infinity f of theta plus 3t is 0, and similarly limit t tends to infinity theta f of theta minus 3t plus 1 by 6 into limit t tends to infinity, that integral is we obtained as 4. So this is equal to uh, 1 by 6 into 4, or limit t tends to infinity u of theta t is equal to 4 by 6, that is 2 by 3. Okay, now we do the C part. So in the C part, we have to find the maximal value of u of xt and the points where the maximum is obtained. Okay, so for the function, for the solution u of xt, we have, there are two functions f, small f and small g. And we know from the equation star, that is u of xt, we have u of xt is equal to 1 by 2 into f of x plus 3t plus f of x minus 3t plus 1 by 6 into integral x minus 3t to x plus 3t g of s ds. This is actually, okay, so this is our solution. Okay, so this is our solution u of xt, and we know that the maximum of f and g, the two functions, will come when we calculate the function maximum of u. So and also for any two real functions, we know that for any two real functions f and g, we have maximum of f plus g, maximum of the functions f of x, the sum of the two functions is always less than or equal to sum of the maximum of each function, is less than or equal to maximum of fx plus maximum of g of x. So actually we have to find maximum of u of xt, that is maximum of the function f plus f of x plus 3t, f of x minus 3t, and the integral function. So this will be less than or equal to the sum of the maximum of each. So let's try to find the sum of the maximum of each functions. Um, and the maximum point is where this such a maximum is obtained. So we have to consider each of the functions f of x plus 3t, f of x minus 3t, and the integral. We know that f of x plus 3t, by the definition of f of x as given, it is equal to 1 when minus 2 less than or equal to x less than or equal to 2, and it is 0 when x is great less than minus 2 or x greater than 2. Okay, so these are the conditions of both the functions fx and g of x. These are the functions, the split function. So we have maximum value is obtained, or x plus 3t, maximum of f of x plus 3t is equal to uh, actually the values are 0 and 1, and the maximum is equal to 1 if minus 2 less than or equal to x plus 3t, which is less than or equal to 2, or that is the maximum is attained, the maximum value 1 of f of x plus 3t is attained on the strip, is attained on the strip. Which strip? That is minus 2 less than or equal to x plus 3t. This is a strip since there are two conditions, x plus 3t equal to the strip, a vertical strip, a vertical strip between from x plus 3t equal to minus 2 to x plus 3t equal to 2. So on the strip minus 2 less than or equal to x plus 3t less than or equal to 2. Okay, so thus we obtained the maximum of f of x plus 3t. Similarly, similarly we can write the maximum of f of x minus 3t also is equal to 1, uh, which is attained on the strip, which is strip, which is attained on the strip minus 2 less than or equal to x minus 3t less than or equal to 2, since both the functions f and sorry f, by considering the function definition of f. Okay, now we need to calculate what the integral for functions maximum. The maximum of integral x minus 3t to x plus 3t. Since g is the same function as x, we know that this has g has a maximum value 1. When this interval lies in the interval, which interval? Minus 2 to, that is x minus 3t to x plus 3t belong to the open interval minus 2, 2. Okay, then only we can split, or we can write it as the sum of these intervals including this one. So for this we can have either this completely belong to open interval minus 2 to, or we can have sorry, or x minus 3t to x plus 3t. So x minus 3t must be less than minus 2, and x plus 3t must be should be greater than 2. Then only it will contain the interval open interval minus 2 to, which contains the maximum value of g, isn't it? Or let me state once again. In order to find the maximum of this integral function, we can have g of x as it has the value 1 when minus 2 less than or equal to x less than or equal to 2, and it is 0 when x is less than minus 2 and x is greater than 2. Okay. So integral x minus 3t to x plus 3t g of s ds will be, or g of x will take its maximum value 1 in this interval. So in this in the interval x minus 3t to x plus 3t, it should attain the maximum value 1 only if x minus 3t is less than minus 2, and x plus 3t is x plus 3t is greater than 2. Then only it will contain the interval minus 2 to 2. Then we can split this interval as x minus 3t to minus 2 plus minus 2 to 2, then plus 2 to x plus 3t, like this. Okay. So in this interval, this will be big 0 and this is also 0. So we have the maximum value as integral minus 2 to 2 g of s ds, which is equal to g of s is equal to 1. So this will be equal to 4. So maximum of g, the integral of g will be 4. Now in order to find the point at which this maximum is obtained is when we consider all the intersection of all these sets. So for the first function to have the maximum value 1, we have x plus 3t. We have x plus 3t must lie in this one, that is minus 2 less than or equal to x less than or equal to x plus 3t less than or equal to 2. And for g of x, integral g of x to have the maximum, x plus 3t must be greater than 2, isn't it? So x plus 3t is greater than 2 and x plus 3t is less than or equal to 2. So intersection, taking all the intersections, taking the intersection of all these strips and all these sets, we get what the set of all points that satisfy satisfy the equations. One is when we consider the intersection of that x plus 3t and x minus 3t, the sets containing that sets having the conditions. First of all, in order to have f of x plus 3t to have the maximum value 1, x plus 3t must lie in closed interval minus 2 to 2. And for the integral g to have the maximum value x plus 3t is greater than 2. So the intersection is the line f x plus 3t equal to 2, or we can write here x plus 3t equal to 2. And for the second one, if the function f of x minus 3t has the maximum minus 1 when x minus 3t lies in minus 2 to 2, but when we talk about this function g, this will be less than minus 2. So x minus 3t is less than minus 2, and x minus 3t is x minus 3t is greater than or equal to minus 2, and from this it is x minus 3t is less than minus 2. So combining this or the taking the intersection, we have x minus 3t, another equation as x minus 3t equal to minus 2. So we will get the point of intersection by solving these two equations, and that points will give the points at which the maximal value is obtained. So adding these two equations, we will have adding these two equations, we have 2x is equal to 0, that is x equal to 0, and adding subtracting the 2, we will get subtracting we will get 3t minus minus 3t, that is 6t equal to 2 minus minus 2, that is 4, or t is equal to 4 by 6, that is 2 by 3. And also for this system, and is there any other solution we can, let's consider. So consider the determinant or the coefficient matrix, determinant of the coefficient matrix, that is 1 3 1 minus 3. Here the determinant is not equal to 0. We can see that the determinant is not equal to 0. Okay. So, since the determinant is not equal to 0, the system in the form Ax equal to b has a unique solution. Okay. So, this is the only possible value, that is the unique solution of xt. The unique value of xt is given by x equal to 0 and t equal to 0, 2 by 3. So, the solution achieves its maximum. Thus, we can say that the solution u of xt attains its maximum at the point, only at the point 0 2 by 3, 0 2 by 3. The maximum value u at 0 2 by 3 is equal to 1 by 2 into uh, f of x plus 3t. X is 0, 3 into 2 by 3 plus f of minus 3 into 2 by 3 plus 1 by 2 into 3, that is 1 by 6 into integral x minus 3t, that is 0 minus 2 by 3, that is minus 2 to 2 g of s ds. This is equal to 1 by 2 into, this will be 3 and 3 get cancelled, so f of 2 plus f of minus 2. F of 2 is same as f of 2 plus f of minus 2 plus 1 by 6 into integral minus 2 to 2 1 ds. Okay, f of 2 is also 1, so this is 1 plus 1 by 6 into 4, so 1 plus 1 plus 2 by 3, that is 5 by 3. So the maximum value of u is 5 by 3. Now the d part. In the D, we have to find all the points where U belong to C2. We know that first for this we have to check the initial points, singularities of the initial conditions. From the initial conditions, given initial conditions, we can see that these are piecewise smooth functions, isn't it? f of x and g of x, or u of x 0 and ut of x 0. Both are the same function which are continuous or smooth except at the point plus or minus 2. Okay. So the initial conditions are smooth except at the point plus or minus 2. Therefore, solution is smooth at all the points that are not on the characteristics x plus 3t or x minus 3t is equal to plus or minus 2. That we know that the singularities of the solution are along the characteristic curves, and the characteristic curve of the given Cauchy problem is x plus or minus 3t equal to constant, and this is characteristic curves along the or which intersects with the initial singularities of the initial conditions at the on the line t equal to 0, that we already discussed in the first problem. So the function, that means we can have, so from the initial conditions it is clear that the initial conditions are smooth except at the points x equal to plus or minus 2. Therefore, the solution is smooth at all points that are not on the characteristics, since the singularities of the solution is along the characteristic curves. The solution will be smooth at all points that are not on the characteristics x plus x plus 3t equal to 2, x plus 3t equal to minus 2, x minus 3t equal to 2, and x minus 3t equal to minus 2. So the solution u is a generalized solution. The function u is a generalized solution. That is piecewise continuous for any fixed time t greater than 0. That is piecewise continuous for any fixed time t greater than 0. Okay.